Okay, I hope I'm recording. I'm not sure if I am. My timer is not moving. Okay, let's just hope we are. Okay, so we are looking at a Taylor series. We are told that we're looking at a function natural log of x. So I'm going to say y is equal to the natural log of x is my function, and I want that center that x equals 1. And I really could use what they're giving me here, but I'm just going to go ahead and do it the good old-fashioned way, and I'm just going to do my building my polynomial just, you know, one term at a time. Okay, so y equals natural log of x. I want to center it at 1, so I'm going to evaluate that when x equals 1, and natural log of 1 is 0. All right, so I know I do not want this term because I want the first 3 non-zero terms, right? So this one is out, so we don't want that guy. All right, so the next one will be my first derivative, and the derivative of natural log of x is 1 over x. And again, I'm evaluating that at the center of 1, so 1 over 1 is just a 1. So that will be my first term that I'm actually keeping, right? And my function name that I'm using for approximating the sum is going to be f, so I'm going to call f of x is equal to, and I want a 1, and that's already going to be my first linear term, right? Because the 0 here was gone, that was my constant term, so I already have my first linear term, and that will be over 1 factorial, which is just a 1, okay? Second derivative. Derivative of 1 over x is going to be negative 1 over x squared, and we evaluate that as x equals 1, and that will be negative 1. So here I'm going to have 1, so it's be negative 1x minus 1 squared over 2 factorial, which is just going to be a 2, so I'm going to leave it like that. Then we need the third derivative, and that will become the derivative of that, right? So that will actually be a positive 2 over x cubed. Evaluate that at x equals 1, and that will be equal to 2 over 1, which is 2. So my next term here is a 2, and I'm going to not write it, and I'm going to show you why. X minus 1 cubed over 3 factorial, right? So I should have that 2 here. That 2 right there should be there. But 3 factorial is 2 times 3, so those 2 would cancel, so I'm just going to be over 3 here. Okay. All right, so this is my f function that I'm using to write the sum of the first 3 non-zero terms. So this will be this one right there. All right, so once you have that down, we're going to use that now to maximize the value of the absolute value of natural log of x minus f of x, and we want to somehow maximize it for x between 0.3 and 1.7. Well, those are, we are dealing with monotonic functions, right? So if this is a monotonic function, we know that the maximum is going to be either at that endpoint or at that endpoint, right? Because they're strictly increasing or strictly decreasing. So I'm just going to, this is technology active, right? Notice. So I'm just going to say, hey, you know, I paid good money for my calculator, I might as well use it, right? So I hope you can see. Sometimes that's hard for me to make you see my screen. Okay, so what I'm going to do is I'm going to enter my function. So I'm going to define it. So I want f1 of x. Okay, you don't see what I'm typing, but I just typed an f, right? f1 of x, and then I want that to be defined, so control, and then this key will define. See that column and that equal sign there? That means define this function, and the function I have is this one, so I want x minus 1, and then I want minus x minus 1 quantity squared all over 2, and then I want plus x minus 1 quantity cubed all over 3. Enter, and my calculator tells me done, meaning, okay, define the function. Now I can enter anything I want to into f1, and it's going to use this function, so the one here that I came up with. All right, so I want to evaluate at 0.3 and at 1.7 and see which one gives me the best or the largest value, right? So I'm going to say f1 of 0.3, tell me what that is, and then f1 of 1.7 will be that. So obviously, because I'm dealing with absolute value, I'm going to look for the largest magnitude, and that will be at for x of 0.3, right? I'm going to get the largest value with my absolute values there. So I'm going to use the 0.3. So what I'm doing now is I'm going to say, okay, then the natural log of 0.3 minus f of 0.3 in absolute value, and I want to know what that's going to be equal to, and that will be my maximum value for that. And so technically that would be your error, right? But they're not even talking about that here. So I'm just going to type that in my calculator. Oops, I hope I didn't lose you. So in my calculator, I'm going to get my absolute value here. And I'm going to say, okay, I want a natural log of 0.3. And I want to subtract my f1 at 0.3 there, enter, and it will be 0.1446, which is going to simplify or round to 0.145, which is the answer we needed. So this was a doozy of a problem for really not a big deal and not much of anything except, you know, writing your Taylor polynomial there for a center at 1 with the 3 first non-zero term, but pretty much that's all. And then figure it out which one will give you the largest value for this here, this difference. That's all it was there. So a big a problem that tripped us all, but that's really not that much of a big deal. So I hope you don't let that define how you're going to perform tomorrow, right? If you encounter a problem like that tomorrow, just kind of move on and come back to it if you have some time left after. But don't let that stop you and think you can't do it, because you can. All right, you have a good night, get some rest.